To understand 5G, we need to answer this question: why all this focus on the 5G technology? 5G was officially introduced by the Third Generation Partnership Project, 3GPP, in December 2017. Through the Release 15, 3GPP organization and its partners from telco vendors, telco operators came with idea of service-oriented architecture, which will help in creating new business cases and new capabilities. In the 5G release, the most network function have been transformed through new service logic, interfaces, and protocols. New type of access network have taken the focus of the 3GPP standard community, such as fixed access, satellite. From business point of view, 5G came to serve and innovate in the IoT business and to offer new business cases based on ultra-low latency capabilities. From infrastructure point of view, 5G have been decoupled from the ATCA hardware, explained in the previous section, and have been designed on a cloud-native environment, taking advantage cloud scalability, availability, low latency performance. 4G falls short as it is merely an evolution of 3G, lacks support for numerous use cases, and has a non-flexible architecture.
When 4G have been introduced in the market in 2009, most vendors have upgraded 3G core software release to 4G and started installing new wireless access dedicated for 4G. That time, the only innovation that came with 4G is the high throughput, which jumped from around 20 megabits per second to around 150 megabits per second as an average theoretical throughput per user. Most of the 4G deployment solution worldwide are on bare metal hardware. The ETSI NFV architecture have been introduced in the market in 2017. That time 5G have been finalized in Release 15, with the integration and technical complexities which limited many telco operators from deploying cloudified 4G on a large scale. IoT have been introduced in 4G standard but did not receive that much support in the market due to the competition with non-3GPP IoT such as LoRa, Sigfox.
Is 5G all about internet throughput?
Ultra-reliable low-latency communication, URLLC, is one of the three primary and the most important use case defined for 5G networks by 3GPP. URLLC is a critical use case which require ultra-reliability, 5 nines, and an end-to-end network latency below 1 millisecond. 3GPP and the industrial community has considered many URLLC use cases. Industrial automation. Factories, robotics, and automation systems need to communicate in real time to ensure efficient and safe operations. Delays can result in manufacturing errors or even safety risks. Autonomous vehicles. For self-driving cars to make instant decisions based on their surroundings, they require rapid data exchange with other vehicles, infrastructure, and centralized systems. E-health. Telesurgery or remote medical procedures demand instantaneous response times and high reliability to ensure patient safety. Smart grids. For efficient power distribution and grid management, timely and reliable communication is essential. Augmented reality. For a seamless augmented or virtual reality experience, low latency is critical to prevent motion sickness and provide real-time interaction.
What is the 5GC?
The brain of the 5G technology is the 5G core network, or 5GC. The 5GC handles subscriber data, authentication, charging, and session management, enabling flexible access and improved performance. The 5G can be deployed through two types of architectures: non-standalone NSA, where the wireless 4G and 5G access network are managed by the 4G core. Most operators have started their 5G deployment with the 5G NSA. The second architecture is the 5G Standalone SA, where the 4G and 5G access networks are managed by the 5G core. The 5GC is intended to manage multiple access networks, such as 5G New Radio, 4G radio access technology, wireless LAN access network, fixed wire access, and non-terrestrial access. Similarly to 4G core, 5GC can deliver voice service like 4G VoLTE called Voice over New Radio or VoNR.
Here are some features comparison between 4G and 5G.